Hi everyone, in this video I want to talk about solving quadratic equations by factoring or using the zero products property. So here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question. If your friends dug up photos of you in the past, which article of clothing would you be most embarrassed to have worn? So in Algebra I, we typically introduce quadratics, and we reinforce it again in Algebra II. Quadratics, you would need to know how to solve, graph, and maybe do a few word problems with. Let's just focus on solving, and these problems in particular are factorable, but some aren't. So I made videos on those as well. Factoring, you always want to check first because it typically is the fastest method that you can use. The other methods are square roots, completing the square, and using the quadratic formula. So occasionally, an ACT problem would have something like this where it's already factored, and you just have to set each binomial equal to 0 and solve for x. So if it said to solve for the directions here, you would take x minus 6 equals 0 and 6x minus 5 equal to 0. Now I want to pause there and think about why that's true. When I was younger, I remember memorizing this and not really thinking about why. So let's think about the situation a times b equals 0. So we have three cases. We basically have, a would have to be 0 and b is a number. We have a could be a number and b could be 0, or a and b equals 0 as our three situations here. So just, to throw out that logic, I want to make sure that we understand, how this process goes. So if I'm going to set x minus 6 equal to 0, I just add 6 to both sides. So x is 6. So that means like 6 could be subbed in there, and then you get a 0 for this whole binomial. If 6 was subbed in here, you would get that non-zero part, and that would be like case 1. And still, the answer would be 0. However, there's something else that we could get for x that would make it make sense, for the whole product to equal 0. So if I solved for x right here, I would get x is equal to 5/6. So I could throw a 5/6 in here. This would become 5 minus 5 is 0. So yeah, that would be case 2 here, where you'd have a number. This is 5/6 minus 6. That would be a number. But still, you would have the situation where the product would equal 0. Also, a and b, this whole thing and this whole thing could also equal 0. So the x could technically be both answers. That's why quadratics typically have 2, with the exception of the special cases. So final answer for these would be not only 6, but also 5/6. Now I'm going to erase these cases and focus on a tougher problem. So what if you had a quadratic equation like this? You see a number in front of the x squared or n squared that is greater than 1. Well, if it's, you might want to check first that it can be factored. So 7n squared minus 11n minus 6, you would want to make sure that 0 is on one side. So I could right off the bat do quadratic formula, but if I'm good at factoring and quick at it, I could probably check that first. So I want to use the the split the middle process here, where I go 7 times negative 6 is negative 42, And I'm just thinking of two numbers that multiply to negative 42 and add to negative 11 because I want to actually split this up. So 7n squared, bring down the minus 6, and there's going to be something here and something here. So, okay, 42, I'm just thinking of all the factors. 1 and 42, 2 and 21. Let's see, 3, does 3 go in? Yes, 3 goes in 14 times. Oh, and there we go. 3 and 14 are 11 units away from each other. So I could probably split this into negative 14n and then plus 3n. So those two numbers multiply to the negative 42 and they add to the negative 11. So now here, I'm going to finish this process by basically factor by grouping. And the biggest factor that can come out here is set a 7 and an n. What's left over? N minus 2. What can come out of the next two? A 3. What's left over? N minus 2. Hey, those n minus 2's match, and so that means that n minus 2 is one of them, one of the, the parts of the answer here, and then 7n plus 3, the remaining two values outside, come together as the next one. So let's check in with what we have. So I factored this into two binomials, and 0 is still on one side. So now I can use that zero product property, set both pieces equal to 0, and I get n equals 2, and n equals a fraction for sure, and also equals negative 3/7. Okay, so not only can 2 work, but negative 3/7 can work as well. Let's try some practice. These problems are just like the ones I just gave you. Maybe a little easier. This one does not require split the middle. And this is kind of an interesting case where the A is by itself on the outside. So I'd like to see how you handle those. And feel free to pause the video before I reveal the answers. Okay. For the first one, 0 is an answer. Also negative 3 is. And negative 5 and negative 2 you would get for the second one. All right, how about a quote to keep you going? This is from Einstein. I really like this. It's not that I'm so smart, it's just that I stay with problems longer, he says. And I think there's that growth mindset again. So I hope this video prepared you or helped you in some way. Feel free to leave your answer to the fun question in the comments. And if you'd like to keep up with new videos, please subscribe. Have a good day.